Thank you. Thank you for that introduction. Yeah, my name is Vadim. I was fortunate enough to be at the right place at the right time, at the right time being like when D3 was being developed, at the right place being right next to Mike Bostock at Stanford at the time when he was working on it, and I kind of got involved with the project very early on. And it, you know, in the early days, I was very heavily trying to popularize D3 and make it a thing. I don't feel like you really need to work that hard at that anymore. But instead, so after D3 was kind of released and being used by everybody, I left Stanford and I went to a company called MetaMarkets, where basically I think MetaMarkets was the first company that used D3 in production, allowing customers to see D3-based visualizations. So I'll just switch back to my talk now. But yeah, and while there, the whole point of MetaMarkets was to do big data. So at MetaMarkets, there was the database developed called Druid, which is really, really fast and open source. And we wanted to allow people to have these really awesome applications built on top of Druid, and with lots of visualizations and stuff like that. And I got really interested in that, and I found myself being really interested in seeing how data goes from the database to the actual visualization. And I'm going to talk about kind of my meditations about this here. It's not really about D3, although D3 is the inspiration for a lot of these things, and definitely a key component. Just so I'm clear, I've actually left MetaMarkets, and me and a couple of guys founded a company around Druid, the database that we developed there. And I am fortunate that the stuff I'm talking to you right now is the stuff I kind of spend my entire day thinking about now, and releasing this into the open source because we're an open source company. So this is really cool. It's much funner to be like, hey, I have these cool ideas and they're open source, as opposed to, hey, I have these cool ideas. All right, see you later. Anyhow, so what's the chasm I'm talking about? Well, you have raw data, you have some data, right? And you have a user that you want to build a visualization for. Maybe it's for you, just to explore that data, but I'm kind of more thinking about trying to build an application for somebody else, some sort of a tool where somebody could analyze the data and see something cool in it. So, well, I mean, first of all, very easy. You have there's a lot of end-to-end tools, things that would just take the data for you and do something no coding required and make a visualization. You can use Tableau and you can use Excel. There's probably many other really good tools. All right, that's the talk. No, I'm just joking. This is a D3 meetup. So obviously, we want to use D3. That's kind of taken as a given. I think I'm happy I'm giving this talk here because if this wasn't a D3 meetup, I'd have to convince you first to use D3, although it's not that hard these days. So OK, easy, cool. We just have raw data, and we use D3 to make a visualization. What could be simpler? Well, in my experience, in the real world, that line doesn't look like that. In my experience, it looks more like this. So you have raw data, then you have a big question mark that is so questionable, I didn't even put it in. It's just an emptiness full of you to project your dreams and hopes into. And then you have the actual data that you will render onto the screen. I mean, at the end of the day, all that D3, D3 is kind of, when I talk about D3, I explain it's really the selection model that's the core of D3. You have some data that you want to map to some elements on the screen. And D3 is amazing at doing that. It has this really nice syntax for doing animations, for doing nested things. And it just works really well. It's very easy, in my opinion, once you kind of get past the initial learning curve to make a D3 visualization. For me personally, I don't want to brag, but it's trivial to make a D3 visualization. I think like once you kind of internalize the syntax of D3, you can just really bang it out, and it's a very convenient tool to use. So this is why this arrow is kind of small, because I feel like once you have the data that you can render into the elements, you're pretty much set. Now, if you look at the D3 examples on like the D3 gallery, you'll notice that pretty much every example, the data in it already is very nicely positioned for being rendered. And that's not by chance, because the whole point of the D3 examples is to highlight D3, not a million other tools that I'll talk about. Well, let's talk about, first of all, D3 is a JavaScript thing. It lives in the browser. Data doesn't usually live in the browser. So, well, I mean, your browser doesn't come bundled with any data sets. So you have to load whatever data you go in there. And I use this as kind of my benchmark of like, well, what kind of things can I load from where? And like, to me, that distinguishes like this problem. Again, like there's no single way to cross that bridge, as you'll see. And I'll talk about like the different kinds. So I break this problem down in my head into 3 sections: small data, medium data, and larger data. Trying not to say big data. So people debate what these things actually mean. So in my definition, like this diagram for me defines what these things are. And basically, if you have a small data file, to me that means you're just going to load all of it into the browser using something like d3.json or d3.csv or jQuery. And then you're going to be like, OK, maybe you use some data transformation tool. Maybe you just write some custom JavaScript. Or maybe you use d3.nest to transform this data into the actual data that will be rendered into the visualization. Maybe it's already transformed. But in the general case, you will perhaps use d3.nest, which is a really convenient tool that comes bundled with d3. In the medium data case, you will probably, like, the medium data is like this middle ground. And to me, it's when you can load the data into the browser. But if you actually want to do something useful with it, you're not going to probably write your own like JavaScript here and there. Or maybe you will, but because you're awesome. But you probably won't use d3.nest. You'll probably use like a beefier tool, like something like cross-filter. Cross-filter, for those of you who don't know, also built by Mike Bostock. It's kind of like the cousin of D3. It's basically a library where you can perform all sorts of data manipulations and then create data that you will then render onto the visualization. And then you have the larger data use case. This is basically where your data is so big that you will not like load it into the browser. And the data set that you guys can download, like that GitHub repo that was up here that we'll play around with later, and I'll play around with it during the talk, it has a data set of that kind. It's basically, so the data set there, and I'll be coming back to it a lot, is Wikipedia edits. So we run a scraper on the IRC channel where like every single Wikipedia edit gets published. This is for bots to, do their machine business. So we just scrape that channel. We just subscribe to these IRC channels, and we like record this data. And what I published into the GitHub is just 1 day of that data. Now, even though it's a single day of data, it has more than 500,000 events in it, because Wikipedia is actually a very popular site. And a lot of people contribute to it every day, which is really cool. And when I say Wikipedia, I actually mean Wikimedia. I mean like all the languages and all the other projects that they have as well. And I tried, so first of all, that file is like included in that GitHub, but it's included as a GZ file because there's a script to to open it up and to like extract the information out of it, because GitHub wouldn't let me upload a file that big. And I tried loading that file into my browser, into the examples that I'll show you later. And what happens is that the browser just spins for a while, and then I'm like, OK, I think it's taking down my whole system. And I try to close the tab, and then 5 minutes later, it says, OK, tab completely crashed, because it's just too much data for the browser to handle. So in that case, you will have like some database powering your application. And again, I know this isn't like the use case for every kind of visualization, because I know, for example, there's a lot of visualizations that are done with D3, and they're really cool, where you have a smallish data set that's maybe like pre-processed, and then you like do a really cool like interactive visualization that doesn't really like touch on big data. For example, Mike Bostock, when he was at the New York Times labs, he would publish all these gorgeous visualizations, like predicting the election, and none of them really required like a huge amount of data. So this is by no means like, OK, you're doing D3, you have like a huge amount of data that you're going to be processing. But to some people, this is like, a lot of people are trying to build cool data applications. And a lot of the skills that come from learning about big data and how to process and to work with data translate really nicely to understanding how to work with smaller data sets as well. This is, like, to me, it's funny because I taught the D3 class at Stanford as the TA, and then it's like the visualization class. And then I guest lectured on that class for a while. And it wasn't until I started working with trying to extract data out of a really big data store that I actually understood a lot of concepts that before I realized I didn't really understand at all. I just knew how to like connect them together and make something work, but I didn't really know why it works. So here's a classical scenario, is that you have SQL. I don't know to how many of you this is an offensive word, and to how many of you this is like, oh, cool, SQL. And then, or some DB query. There's a lot of databases out there that don't use SQL as their interface. They maybe have their own JSON interface of some sort. And then you get the data back from it, and you do some manipulation to it, and then you render this data using D3 and present it to the user. So this is all cool, and all of these use cases, they seem pretty like equivalent until you start thinking about interaction. Interaction is kind of like the thing that really throws you off your game. Because if you want to make a visualization interactive, and I mean sort of not basic interaction, like, oh, I added a hover tooltip over this thing, or the interaction you very often see. I have a like, it's almost like a pattern in the D3 examples, the make it red on hover. You've probably seen that. So if you're going beyond make it red on hover, or a tooltip with more information, maybe you have some sort of a click and filter onto that thing and issue like a new query logically, or somehow, or you sort something. If you're doing any kind of interaction that actually manipulates this data for viz, the stuff that you're actually going to be rendering onto the screen, then well, these are the interactions I'm referring to here. And in the small data case, because you loaded all the data into the browser, whatever new things you need to compute on top of it, you do it in the browser, and everything is very easy. Like your life is easy, everything is good, and you don't even have to understand anything properly, because there's plenty of tutorials that will take you through it. If you have medium data, well, you can use a tool like cross-filter. I'm sure there are other tools, but I kind of stay in the Mike Bostock fan group land. So you could use cross-filter, and cross-filter, like, if you use it, you'll be like amazed by how much data it can actually crunch. It can like easily handle quarter million events, like really smoothly, like if you look at the cross-filter demo. And again, all your data is loaded here. Maybe this initial data load took some time, but afterwards, you have a fully interactive visualization. And that's cool. I'm not trying to suggest that you should do anything different if that's what you're doing. I'm not really trying to suggest you should do anything different at all. I'm just trying to convey a cool concept, which I'm about to get to. If you're working with the larger data case, your interaction actually has to go back to the database. You actually have to craft a new query, get new data out, retransform it, and your transformation might need to change based on that query, based on like the interaction that happened, and then you have to render that. And to me, this arrow is really what was the pain. Like this arrow, the fact that it crosses back into the back end and does things, this is what made me realize that my knowledge of all of this stuff was really insufficient. Yeah, so this is really the use case I'm going to be focusing on here. And the cool thing about this use case is that I think if you understand it, you can if you can do this, you can do any kind of, you have the data kung fu to handle any kind of data that's thrown at you, be it big or small. I'm going to show you like a conceptual, logical thing, but it's not, as I said, like the cool thing about working at an open source company is that you don't have to say, okay, well, I have some cool ideas, right? Have fun implementing them. I mean, you're obviously more than welcome to implement them, but you can also check out a thing that we recently open sourced that's pretty new called Plywood, which is basically an implementation of the ideas I'm going to be talking about here. But again, the ideas hopefully translate to beyond the data. And at the core of it, and this is the thing that I started on my research when I realized my knowledge was insufficient, and this is where I was like, aha, I found the thing that can explain how data works to me. At the core of it is a split-apply-combine principle. Maybe if you've seen my talk before, you've seen me exhale it previously because I love to talk about it. Maybe this is completely new to you. It was popularized by Hadley Wickham, who's, in case you don't know, is kind of like a big deal in the R community. He wrote dplyr, and this is the dplyr paper. And dplyr is like dplyr is to R what jQuery or now D3 is to JavaScript. And basically, like it's like R is like for statistics people who really like to nerd out on data transformations, and this is like the #1 tool for them. What split-apply-combine is really just a way of reasoning about how to manipulate data. And I find it a very intuitive way to think about it in your head that really clears stuff up accordingly. There's a sort of, I think, a quote, I don't remember who to attribute to, but the right mental model is equivalent to 20 IQ points. And when I read this, it set my mental model of how data works correctly, and I was happy to receive 20 IQ points. So the center of split-apply-combine are 4 operations: filter, split, apply, and combine. And filter is basically like, it's so simple it doesn't even get mentioned in the title name. It's like, you have some data, and then you apply some predicate. You have some like function, some like where clause that goes over every single data point in this data set and just says, okay, you're in, you're out. And this could be like, okay, I have like my Wikipedia edits for the entire Earth, but I'm going to only focus on the United States of America. So I'm filtering only United States of America. Split is the operation that is the most interesting one out of all of these. It's very, very similar to something called group by in many other languages, like SQL and it's map and MapReduce. It goes by different names. It's very commonly called group by, and the cool thing about there's a good reason for calling it split, but I'm not going to get into that now. But essentially, it's like you have a big chunk of data. Like imagine like a big bag of like little data points, or maybe like a physical bag of something, and then you split it up into several smaller bags, and you like each smaller bag has a partition of your original data by some attribute. And the cool thing about split is that you can actually nest it. Like if you think about it, you can have like a big bag of something, like maybe you have a crate of, all sorts of drinks. And then you can split it up by like alcoholic beverages and non-alcoholic beverages into 2 separate crates. And then each one of those crates you could split up by like, maybe like the type. And so the alcoholic ones would be like beer, bourbon, and then like the soft drinks one would be like carbonated or like whatever. And it's a very natural way of thinking about it. Just a quick note of like why I think the word split works better than the term group by, which is very commonly used for this operation, is that if you group something into groups and then you group it again, then you're grouping the groups as opposed to like the events inside of the group. If that didn't make any sense to you, don't worry about it. As I said it, I was like, I shouldn't have said it. I'll probably write a blog post about that once I get my thoughts straight up on that. Apply is just, okay, I have a crate of something, like I have a crate of drinks, like count them, add up their weight, like perform some calculation that scans all of them and does something. It's commonly called aggregate or measure, but apply is a good name because you're applying a function to like a crate. And finally, combine is you took your like one thing and you split it up into many things, and then you just want to give them some order, some logical sense. So for example, you could take it up and you can say, okay, well, let's look at all the edits in Wikipedia for the world, and then let's split it up by country. So now I have like individual buckets, each with a country. And now I'm going to count, I'm going to apply how many edits I have in each bucket. And then I'm going to say, okay, let's combine it. Let's sort it by a descending order. So we have the top countries and like with the most edits first, and then the decreasing ones. And then I'm going to only take the first 10 because I'm only interested in the 10 most contributing countries to Wikipedia. And again, the real beauty about this operation, to me at least, is that it really works well with nesting. And you'll see that nesting is going to be kind of a common pattern throughout this talk because D3 is really good at nesting. And when you have everything in your like thought space and your tool chain good at nesting, you get great results. So SAC, split, apply, combine, as I say, let's talk about where we can find it. So here's a visualization that I made. And by made, like most of you, I went onto the D3 website, copied their grouped bar chart, and then tweaked with it until it did what I wanted. This is in that repo that I shared. It's maybe a little nonsensical, but basically what it is I filtered my data to only United States and only edits that were tagged with a location, which is a very small amount of edits. Most edits on Wikipedia aren't tagged with a location. This actually reduced my data set so much that I didn't have to do, it put it in the small data camp, which is cool. Like this whole talk is invalid. But I can still talk about this split, apply, combine idea because it permeates everything, even small data. It's just not as important that you understand it if you're only going to deal with small data. So first of all, I said, okay, for every split up by state, and then within each state, count the number of edits that happen in that state, and then give me just the top edits. Like this is kind of what I'm trying to convey in this visualization, right? If you just looked at this visualization, assume it had titles and labels and all the things that you need to get a passing grade at a data visualization course. Well, basically, you would be like, oh, well, why are there 5 states? I know there's more than 5 states. I bet these are like the top states by edits. And then within each one, I divided the day into 4 parts, like 4 quarters, midnight to 6 a.m., 6 a.m. to noon, noon to 6 p.m., and 6 p.m. to midnight. And then I just counted up the edits within each one of those buckets to see like when sort of people are being active on Wikipedia. And this is all in just one day of edits. This is September 12th, 2015. And I created the visualization like this. And now, if you just look at it visually, you see that there is actually a level of nesting here. Because the first level of nesting is reflected by the states. You have 5 panels, 5 groups of things. And those 5 groups were determined, through a split. And then within each one, you have four bars, 4 things that were somehow determined through another split. So you could call it like, if this was a fancier visualization, I might use like a layout here. A layout really is just a manifestation of a split, like internally. So let's say we're trying to, let's kind of break this visualization down and see how we might go about generating it. Well, let's say this data was in a SQL database that we had to access. We might run a query like that. And basically what we're doing here, so this is just a query to compute the top 5 states by the number of edits. We would say, OK, select region name and call it state, count star as edits, and then from my table name, and then I'll group by the region name, and then I'll order by the edits, and I'll take only the top 5. Now, the funny thing about this is that this is really SplitApplyCombine, except like a little bit out of order, which is why I always find writing SQL statements a little annoying. By the way, like a quick rant about SQL. Why SQL? Why do you put the group by last? If I had my way, and maybe I do, I'll put group by as instead of select. Like, I don't care about select. I'd be like, I'm grouping by region name, and then like, what am I aggregating by? Not write a query where up until I write half of it, I don't even know why, or like what kind of query it's going to be. But then again, I'm also the kind of person that thinks that the Spanish way of writing upside down exclamation marks and question marks in front of sentences is a really superb idea. Because, why not know up front what kind of a statement is going to be? OK, so basically, a SQL statement is written in the apply, split, combine order, where you first define your applies, and then you later say what you're going to split on, and then how you're going to combine. That's cool. But as you remember, in the visualization, I actually had 2 levels of nesting. Well, you can't do that in SQL. SQL was fundamentally built for, if you've ever used d3.nest, you know it, like the whole point of it is that it outputs a nested data structure to you, a nested JSON. SQL was always, like the fundamental core idea of SQL as a language is that like the primary unit of thing in it is a table. So it operates on a table, and if you join 2 tables, you just get a new like virtual table, and the output of it is always a table. And the cool thing about a table, or like the uncool thing, if you ask me, is that they're always flat. So in this case, if I wanted to have a region name and a day quarter, I would then have to, well, I'd have to do like group by on both of them to get like a cross product of those, like a kind of a matrix, if you will, of for every region name and for every state. And at this point, notice I can't really specify a limit or a sort because, well, I mean, this is like one table at the end of the day. So how can I sort it to only get the top states? It's possible that if I just sorted it by like the edits and I took like the first some amount of it, I could miss out maybe some very popular state that for some reason is like always asleep at a particular part of the day and never does edits at that point. So this is the SQL I would run. But this SQL, I would send it to the browser, and this would not be enough for me to actually render the visualization. And this is where I would use nest. So d3.nest is a d3 helper function that comes with d3. You've probably seen it around because it's used in many examples. It's kind of like the glue that holds a lot of the data stuff together. Basically, you could tell it to, well, so it calls splits key. And it calls apply rollup. So go figure. But basically, you do d3.nest, and you say, OK, key region name. OK, my key is like the region name, so group everything by region name. And then within that, like do something with the raw events. And I can actually show you the output of this because I have my trusty visualization here. So this is that visualization using d3.nest under the hood. And the output of d3.nest is, OK, let me make this bigger. The output of d3.nest is an array of things, and then inside of it is a key, and then in that it says values, and then in that it's another one of these arrays. It's a nested data structure. It repeats itself, and within that it's key like 0, 1, 2, which is how I like call the quarters of the days, and then within that I could have the raw values, but because I specified here that I wanted to calculate their length, because basically to count how many values there are, it just puts a number down for me. And it gives me this nested object to play with. The reason that this function exists is because that's exactly how D3 expects this data to be given to it. So if I move on to the next, yep. So if you look at D3 selections, and again, this is, to me, this is the most beautiful part of D3. I think D3 did a lot of things right, which is how it became a very popular toolkit. But I think D3's biggest contribution to, D3's two biggest contributions to like sort of API design of visualization toolkits from an academic standpoint is nested selections, which is what you see here, and also how it declares animations, which is really beautiful. But what you see here is that basically, first, you're going to, every time you do a .data call in D3, it's basically saying, like, use a split, right? It's not quite, you can't really call it split because it's not actually splitting any data up, but it is sort of splitting up what this thing now talks about. So there's a lot of similarity there. Again, just recognizing that these concepts, like if you ever saw an example using d3.nest and didn't quite understand why it needed it, and you tried to take it out and it, like everything fell apart, this is why. Because basically, the way D3 works is that here, here you have just one SVG, right? And you do this thing where you say, okay, select all state things in it and attach data to it, and then do this like mapping voodoo that will create a state thing for each one of my data things. And the way this works is it's kind of like if you imagine having, like the way I imagine it is like having like a tree with progressive branching, and like D3 is like a thing that consumes it one layer at a time and like outputs something out of it. So in this case, this is going to create a bunch of G elements. And G elements are groups in SVG. So if we go here and we go inspect element, we see that the structure of this visualization is just like I said, it's nested. You have state, 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 like 5 groups that each represent a state, and each is bound to that state's like data of 4 things. And then within each one of them, you have bar, 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 4 bars, 1 for each thing. And you could imagine like continuing this process indefinitely. In fact, like if you think, oh, like wait, how common are nested visualizations? Well, any visualization can become nested if you like repeat it multiple times. It's called small multiples. Like you can imagine having a map, maybe like a map of like, well, basically for any like visualization, you can think of it as having a map, and then you take some attribute that you haven't like exposed before in the visualization, and then you make several maps with that attribute changing between that. So for example, you have like a map of check-ins of like users of your mobile app. And then you say, well, I have this attribute of gender. Now I'm going to say, okay, I have like as many maps as I have genders defined in my schema, like one on top of the other, just showing like check-ins of women, check-ins of men, check-ins of unspecified. Or maybe you have like some like a pie chart of like something, like you have a pie chart of like your sales percentages. Well, if you have in your data, you have something, let's say you have 2 dimensions like a publisher and like a content consumer. You could make like a heat map, basically like a little grid table where you say publisher, 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 content consumer, content consumer, content consumer, and then fill in every cell in that table with a little bar chart, with a little pie chart. So any visualization can really become nested. Just like here, you could really say this visualization is just a nesting of like a humble bar chart. Like this could be, I could have made a bar chart of just all Wikipedia edits across these 4 quadrants, but then I said, nah, I'm going to split it up by state because maybe that's interesting to me. So this, and this is the whole like coolness of D3. The cool thing here is that I don't know like how obvious it is, but the syntax doesn't change whether it's your first selection, whether it's your first split, or your next split. Here, this thing all works within one SVG. Like within one SVG, you're going to create 5 things. Like, if you didn't care for D3 much, you could do this with a for loop, right? But here, like at this point, you would have to like nest the for loop inside of the other for loop. What D3 allows you to do is actually just say, well, I have the states that define like the state containers that I have, and within each one, I'm going to populate it with the hours of the day for that state. And that's a very powerful thing. And you know that you're dealing with nesting whenever you see data being specified as a function. So here, data is taken from values. This is the actual code that's powering this example, and you can download it and play with it. The one thing that's a little bit annoying about d3.nest, like this is the buyer beware if you start using it, is that it calls everything key and values at every level, and it gets very confusing. At least it can get very confusing. It took me several tries to write this example down without like sort of putting the wrong, like I was like, at the end of the day I was like, okay, something is called keys, something's called values, and then I just kind of permutated them until the whole thing worked out. And here, essentially, like logically, as I said, the data is a split, and then the setting of the visual attributes to individual subcomponents is the apply. And there's no real combine because you already combine, like you already like sorted your data somehow. In D3, there's no way to say like, hey, only show me half of the graphs unless you truncate the data yourself first. And then, so this is how I do it in Plywood, which is like a thing that I wrote. And essentially, it kind of exposes SplitApplyCombine a little bit more. It's more upfront about what each thing is. So essentially, you write this query when you say, OK, I have my thing called Wikipedia, like my wiki. It's like all the Wikipedia data. Although here, this is Wikipedia data that's already been filtered on the United States. And then I'm going to say, OK, ignore the region name null ones, because those are like weird errors. And then split by region name. And then within each one, count up the edits, sort that, provide a limit, and then apply a, and then within each one of those, split it up again by day quarters, like the quarters of the day. Now, the way, like after running this spits out a data thing that kind of like d3.nest has a state and a quarters and a day quarter. It's the same thing as d3.nest, except it actually, like you can name these things as something other than keys and values. And kind of the advantage with Plywood is that it deals with generating the query for you under the hood. So you just kind of, you can think of it as working with d3.nest, but under the hood, it can actually interface with a database completely opaque or opacally to you. You don't have to care about that. So let's see how this manifests itself. So this is the same visualization written in Plywood. Actually, the states that are being shown here changed because I didn't have, d3.nest doesn't allow you to sort things, so this is not sort. The states here are just not in any particular order, while here they're the biggest ones. I started writing this talk, and I thought I remembered that d3.nest had a sort operator, and then it didn't have one, and then I panicked, and then I was about to make a pull request into d3, and I was like, no, let's just finish this as it is and see it. But yeah, to do this properly, you would have to run like a smarter query first on your database to figure out which are the top states in the first place, or just do it in JavaScript. So here it's just truncated to some number of states. And yeah, what I'm trying to drive home here is not, OK, everybody go out and download Plywood. Far from it. What I'm trying to say is, if you think about these visualizations as SplitApplyCombine, then you can start thinking, you can start mapping every tool onto that framework. And from my personal experience, that mental model was very, very effective at streamlining everything. In fact, when I literally, if I go to the, to the D3, whenever I look at visualizations, I go to the D3 examples and, I look at any of them and I think, OK, well, what do we have here? Oh, it's a split by state and then a split by county within that state. It's a nested split. And if we had 5 of these maps next to each other, there would be 3 levels of nesting. That would be cool. And then you can literally do it with any one of them. You could say, oh, what is this? Well, it's a split by whatever these things are, and then a split by time. And because that maps to how the visualization will be rendered and how it will be made in D3 and how you will have to fetch the data for it one way or another, it's a very effective way to think about it. By the way, here's a cross filter. Here's the cross filter library. It's this is the library that can do a ton. This is the medium data library that I was talking about. It can scan a huge amount of rows, and all you have here is really you have some data set, right? And then you have a split on time right here, a split on arrival delay, a split on distance, and a split on date. And they're just sitting next to each other, and they're all tied together. And cross-filter allows you to do this operation really neatly. Just thinking about it, this is the way that I sketch out visualizations. And this is useful even if you're doing a visualization that has no big data backing to it whatsoever. I'm pretty much, oh, cool, a Gantt chart. I'm pretty much done with my talk. I want to see if anybody has any questions and then move to more individual hacking sessions. But what I want to kind of So you can try all of these examples out yourself and play around with a big data set. If you, the exercise that you have to do if you want to really get this, and I've had several people do this, and all of them were like, oh my God, I get this at the end, is try to make a visualization on top of more data than you can load in the browser, and have that visualization be nested. And you don't have to be creative here. You can just go to the D3 homepage and find some nested visualization and try to make that just run on top of a big data set. And that's like an exercise that, regardless of your skill level of D3, will teach you a lot about how to think about data. And hopefully, SplitApplyCombine and that paper that I mentioned before, that if I click here, I think I linked it in the README here. It's called, I think, SplitApplyCombine for data analysis. If you just, in this paper, just read the intro, this paper literally changed my life. Just read, it's a paper that just ignore, when you get to motivation, just forget about it. You only need the first part. You only need this page. This page, I should probably print it out and frame it because it's the most beautiful thing I've ever read. The rest of the paper is extremely technical and very, very R-nerdy to a point where I haven't actually met anybody who read through all of it. But hey, the first page is so mind-blowing that I'm cool with the rest of the pages. So that's it. That's what I wanted to say to you. You're welcome to check out Plywood. It's in a pretty nascent state, but it's being worked on pretty rapidly. It's cool. It supports Druid and MySQL, so you can easily create visualizations on top of those, and it's completely a pack to you which one you tell it which one to use. It's not randomly going to find a database to connect to, but the interface is completely consistent between all of them. But more importantly than that, I want you to go and apply thinking of SplitApplyCombine to every data problem you see from now on. That's it. Thank you.